All right. Welcome to our Friday homework today, right? CPM lesson 5.1.3. Okay, and I'm really missing having you guys in class for this. There's actually a little Ed puzzle video I might share with you guys on this one because it's kind of cool to see a visual representation of multiplying fractions. And it's kind of cool to see. So we kind of would have done that in class. We're going straight into some review and preview, most of it review of things you've already done. So let's just go ahead and do this. And maybe later you'll come up with a little video to watch, right? A little quick one. Hey, Edgar Degas, all right? Degas is how you pronounce that. Famous painter. Go check out some of his paintings. He was an impressionist, is what they call it. There's a certain time in the late 19th century, early 20th century, when they were painters and they painted a certain way. Very cool. Monet's probably the most famous, and Renoir. But I really like Edgar Degas. He painted some real life things. One of my favorite American artists painted a lot of funny paintings. Got to go see his museum a couple times in Western Massachusetts. His name is Norman Rockwell. Might Google him. Maybe I'll have him be one of our names doing math homework next week. Anyway, I circled this in red because we start doing this homework, and if you're working out of the book, right, you do this page and you get to 527, you think you're done. No, there's another one. Okay, so I circle that in red. Make sure you don't forget about that last one. Let's get busy. Okay, we have mixed numbers and improper fractions, and we are converting, one to the other. So on this first one, we have 4 1/3. And how do I make that into an improper fraction? You guys remember? ABC method, right? So again, you multiply. And why are we multiplying and then adding? Because each one of those 4 whole, right? You say these rectangles represent a whole, right? Why did I draw them like this? Because you can easily see that's 3/3, 3/3, 3/3. So 3 times 4, where's that? There's a fourth one, is a total of 3, 6, 9, 12 thirds. That's why we're doing that. Then I'm going to add that last third. I'm going to turn this one sideways and say that's what we're doing there. Okay, so 4 times 3, 12 plus 1 is 13. And that goes on top. What goes on the bottom is the same thing was on the bottom when we started. Okay. Now on B, we have 15/4. How do you get that? Well, you divide the bottom into the top. Okay. 4 goes into 15. And I'm going to do it over here as I double check this and have you do that one. Okay. So if I wanted to double check I did this correctly, I'm dividing the bottom into the top. If I want to convert this to a mixed number, and I go 3 into 13, and that goes 4 times, because 3 times 4 is 12. Now here's what happens. Your remainder goes on top, becomes your numerator. The divisor, what was on the bottom, goes on the bottom, back where I started. Okay, so you can do both of these if you want on all these and double check. Both change the mixed number to an improper fraction if that's what you're starting with, or an improper fraction to a mixed number. But you can change it back to see if you did it correctly. And when you do that, it's a little bit more work, but you get a little bit more practice. Okay, so 3.5. How many halves is that? Right? And D, 15/8. You're dividing the bottom into the top. I think you can do those because we've done quite a few of those, especially if you're doing the warm-ups, right? Do the warm-up. The homework's easy. Do the warm-up and the homework, right? On this one, I want you to write in big letters, bold, caps lock, of means what? Okay? Hopefully you're shouting out, multiply. Okay? That is a great thing to know. It'll help you so much with word problems. Okay, so if you want to figure out what is 2/3 of 3/7, or if you want to figure out what's 1/2 of 3/5. You could just think, what's 1/2 of 10? Almost everybody in here says half of 10 is 5. Well, what's 10? 10 is the same as 10 over 1. Okay, so you write it out, but then put a big X through the word of, so you know you're going to times. Okay, now multiplying fractions is what? Hopefully you shout it out easy, right? 1 times 10 is 10. 2 times 1 is 2. And that simplifies, right? 2 goes into 10 5 times. It goes into 2 1 times. 5 over 1 is the same as 5. And we said half of 10 is 5. Means the same as multiply. Okay. You go multiply these straight across the top, straight across the bottom. And on this first one, you'll have to simplify when you get done. But not too hard. Okay, when you're multiplying by powers of 10, by 100, right? By 1,000, by 10, by 1,000,000, okay? Last year and in previous years, your teacher told you when you multiply by 10, just add a 0, right? When you multiply, so you get 170. By 100, add 2 zeros, okay? I've been trying to get you to change and say something a little bit more difficult that'll help you a lot more. Instead of saying add a 0, say move the decimal over 1 spot for each 0. So here, if the decimal was here for 17, move it over 1 spot, you still get 170. Okay. Here, the decimal is here, moved over 2 spots for 100. Go in that carton, you still get 1700. Okay. Now, why am I having you do this then? Well, what if you had a decimal? Okay. Are you going to add zeros? No. Okay. So this now, if you start thinking that way, moving the decimal over a certain number of spots, depending on how many zeros, right? Then you can multiply decimals and it gets much, much easier. And when we start dividing by 10, 100, or 1,000 powers of 10, you know you just move the decimal the opposite way. Okay, so it becomes much easier in the long run if you learn it that way instead of adding a 0. So 68 times 100, I'm going to move the decimal in the 6/8 over how many spaces? 2 spots. Okay, have you do that. But now this becomes easy. 0.68, 68 hundredths times 100. I'm going to move the decimal over 2 spots. C, 6.8. By the way, see how I do this half parentheses after the letter that designates the problem? Make sure you're doing that, okay? Because we're using letters for variables now, and you don't want it to be confusing what the problem is. So 6.8 times 1,000, I'm going to start with that 6.8, and I'm going to move it over 1, 2, 3 spots, okay? You go give that a shot. I showed you how to do it. I think you can do that. Okay, on your own graph paper, draw a rectangle with a width of 6 and a height of 8, and then draw a similar rectangle enlarged 300%. I'm going to have to do that one on the back. Okay. Okay, let's just do that one on the back. I want some more room. Okay, so 527. Width of 6, height of 8. I'm going to not do centimeters. I'm going to say each of these boxes is a centimeter. 3, 4, 5, 6, 7, 8. Width of 6. There's 3, 6. All right, I have a rectangle. This is 6 and this is 8. We're going to say those are centimeters. And now, okay, it says to draw one that is enlarged. Enlarged, is that going to make it bigger or smaller? It's going to make it bigger, right? By 300%. Okay, so what is 300%? Well, if I move the decimal over 2 spots, that's 3 times bigger. Okay, so every one becomes a 3. So that's a 3, another 3, another 3, another 3, another 3. How long is this? 6 times 3. So now it's going to be how wide and how tall? I think you figured that out. Okay, so you're going to do that. If you have graph paper, it's better. If not, you got to sort of eyeball it or measure and try to make it look uh, proportional is the word. Okay, now draw a similar rectangle with lengths that are 2/3 the original lengths. Okay, so what do I got to do on this? I got to figure out what is 2/3 of 6. Well, what does of mean again? How do I make 6 a fraction? Okay, and then next question, what is 2/3 of 8? How do I make that a problem? How do I make that a fraction? All right. And then so you are going to figure out the dimensions of this other rectangle and draw it down here. Okay. All right. Last one. Cruising. 5-28. What do we got here? Sophie claims that whenever she increases the perimeter of a rectangle, its area increases. She showed a rectangle and said, if I make the base twice as long, then the area increases. Is her statement correct for this figure? Okay, so let's see. She has a rectangle that's 3 by 6. And if she made the base twice as long, right, then the area increases. Okay, so right now, what is the area of this? Well, I got 3 rows of 6. 3 times 6, that's 18, and we call that square centimeters. Now, what if I made the twice as long? Will the area increase? I'm going to have you figure that out. Okay. And it says draw a diagram of the rectangle she described. We did that. And explain whether the area is greater than or less than the rectangle on the right. Okay, so I think that's easy enough for you, but don't forget, you need to explain. That is a weakness, right? Because most of the time we say, oh man, this is the last problem of the whole assignment. I don't want to explain. I'm going to leave that part blank. Well, you will lose some points if you leave that blank, because we need to get good at that, because they test that. Okay, that's a skill that you need to know, how to explain things. Okay, it's hard sometimes to put it in your own words. The key for me, the hint for you on when you want to explain something is just pretend like you have like a second grade brother or sister or cousin, and you wanted to explain something to them. That ends up making you put it in simpler terms, which is a better way to explain things when you can. Okay, so that's my hint for you. All right, last thing, B, is her claim. I'm sorry, you can't see this, can you? Is her claim about the relationship of the area and perimeter correct for all figures? For example, is there a way that she could make a rectangle that has a greater perimeter than your figure in part A, but the same area? So what is the perimeter of that? Okay, first off, that perimeter of that, remember, that's the distance around. You measure this 3 plus 6 plus another 3 plus another 6. So 2 3s and 2 6s, or 3 and 6, that's 9, and another one. The perimeter ends up being 18. Okay, so they're saying, can you have a rectangle with a perimeter of 18, a rectangle with a greater perimeter, a perimeter more than 18, but it still has the same area. And the area we figured out was 18, and the perimeter was 18. Can I have something with a area of 18 but has a bigger perimeter? I'm going to have you think about that, try some out, and see what you get, and come back and see what we decided tomorrow. That's one of those I'd like to have you try it. Okay, and I'm sorry I had some of this recording off the screen in here. Right, I got to get this centered more. So flipping the page. All right, you guys. Happy Friday, everybody. Have a great weekend. Hope you stay dry and safe, and hopefully the ground gets lots of water and our reservoirs fill up. Okay.